Dear students, welcome to the lecture series of thin film deposition technology. And today we will discuss about one of the most important type of physical vapor deposition technique known as sputtering. Students, the sputtering process is defined as the process of physical evaporation or physical removal of the source or target material on application of a highly energetic projectile ions. So in this process, basically the source material, which is the material we need to deposit as a thin film, is removed upon the application of bombardment of highly energetic anions. When the energetic anion removes the source material, this source material gets evaporated and transported onto the substrate surface, which result in a condensed thin film. So, dear students, it is very important to understand that in order to remove the source material from the surface or from inside the surface, we need the projectile anion with higher energetic energy than the binding energy of the source material atoms. If the binding energy of the projectile of the source material is less than the energy of the source material, there will be no physical removal of the atoms or ions from the source materials. Okay, so another factor, the key factor, is the energy at the surface and energy inside the source material. You know that the atoms at the surface of the source material have 3 degrees of freedom, so they require less energetic ion energy and they can easily be removed from the surface, whereas in case of this atoms of the source material inside the material, they have 2 degrees of freedom and they require higher energetic ion energy to remove them inside the source material. So the binding energy is key factor for the physical removal of the precursor or source material, and also the energetic ion energy is also the key factor, and it should be higher than the binding energy of the source material. With the sputtering phenomenon, we can deposit elements, alloys, and wide range of complex compounds. Okay, if I discuss this in terms of industry, the sputtering devices basically are most commonly used for depositions of the contact material. We usually deposit different types of electrodes and capacitors, like in planar capacitors or out of planar capacitor, using these sputtering devices, using the sputtering process. Now coming toward the types of sputtering. So sputtering is basically divided into 5 different types, okay, known as the DC diode sputtering, RF sputtering, DC triode sputtering, magnetron sputtering, and reactive sputtering. All these physical processes basically use the ion as a bombardment source, but in all these physical processes there is certain type of the changes, such as in magnetron sputtering we use the magnetic coils or magnetic rods along the side of the ions. So we will discuss all these processes in next lecture series. For here, we will just simply explain the DC diode sputtering, okay, which is the simplest type of sputtering process. Dear student, in order to know the sputtering process, it is very important to understand how the ion will interact, will react with the target source material, because sputtering is basically a physical phenomenon of interaction of ion with the source material, with the surface of the source material or inside the source material. Okay, so ion have a certain amount of energy, and with this energy these ion with the source material may be reflected. They can cause reflection, they can be rebounded on the application of bombardment. Ion may stick with the surface of the source material depending on the energy of the ion and also the property of the source material or property of the surface of the source material. Okay, so the bombardment ion may cause sputtering. They can cause as physical removal of the source material. Okay, bombardment ion may cause the ion implantation, and they may cause a chemical reaction on the surface or inside the source material. The bombardment ion can cause the emission of the electrons, that could be secondary electrons or tertiary electrons, and also the emission of the photons. Dear student, it is very important to understand that all these physical phenomena like emission, reflection, ion implantation or sputtering have required this certain amount of energy from the ions. Okay, and the certain amount of the bombarding ions. So for absorption or reflection of the ions from the surface of the source material, they have energy less. The ions have the bombardment ion have energy less than 5 electron volt. In case of if the ion have energy in the range of 5 to 10 electron volts, they basically cause a surface damage of the source material and migration. So in this energy range, basically the ions are causing the damage to the surface of the source material or the precursor material. If the energy of the bombardment ion is in the range of 10 to 3 kilo electron volts, they can basically knock out the atom in the source material, and they remove the atoms of the source material, causing the sputtering. If the energy is greater than the 10 electron volt, with this higher energy, basically the bombardment incident ion result into a physical phenomenon known as the ion implantation. Now coming to the processing steps, that what are the key steps of the sputtering processes. Dear student, every sputtering apparatus basically work on these key processing. First of all, in the sputtering device, we need highly evacuated chamber. Okay, the sputtering chamber is basically because the deposition is possible in high evacuation, and if there is no vacuum, this will cause a lot of contamination, and the transport of the gas or the transport of the source material as a vapor will be very difficult. So the key processing step of the sputtering process is evacuation of the source of the chamber, and the chamber is in this process is basically evacuated in the range of 10 to the power minus 4 to 10 to the power minus 6 torr. After the evacuation, the sputtering chamber there is an ionization, and ionization, because we need to ionize the inert gas in order to bombard them on the source material. Okay, and this gas is basically ionized. If we have a simple sputtering setup, the inert gas is basically ionized on the application of high potential, which is in the range of kilo electron volts. So how the sputtering inert gas get ionized. Okay, we use basically in sputtering apparatus high potential. This potential is basically applied across the cathodes and anode, and due to this they basically discharge and they cause the ionization of the inert gas. The argon is basically get ionized into argon plus and electron, and this argon plus is basically then used uh, as a bombardment ion. Okay, after the ionization, this the argon gas is basically they get targeted, or they get impinged on the target with a higher energy. Okay, and after striking basically the target after striking the high energetic ion on the source or target material, they basically cause a physical removal of the source material, and this removal could be in atomic or molecular scale. Okay, and then when the target material or source material is basically removed or is evaporated, and they moved or travel toward the anode, which is basically on which we have a substrate in the sputtering setup, and they get deposited onto the substrate. Now coming to the design of the sputtering apparatus. Okay, the simple design of the sputtering apparatus is that the sputtering apparatus consists of a vacuum chamber, a sputtering chamber, a chamber in which the sputtering process will occur. This chamber is get evacuated by vacuum pump, which get evacuate vacuum chamber in the range of 10 raised to the minus 4 to 10 raised to the minus 6 star. In the vacuum chamber there is an argon inlet. Okay, so with this inlet the argon gas is basically transported, or argon gas to move inside the vacuum chamber, and this argon gas is basically a key which will be used as a bombardment ion. Okay, this argon gas will be get ionized. The sputtering chamber consists of anode, cathode, and the source material, the material which we want to deposit, will be placed on the cathode, whereas the substrate is placed on the anode, and these both the cathodes and anodes are connected with high power source. In processing, basically the argon gas enter via the inlet, and on application of high potential, this argon gas get ionized. So this is the ionized argon atoms. Okay, ionized argons, and these are positive Ar plus argon ions. So these argon ions basically incident or strike onto the source material. This is the material which you want to deposit, and they result in ejection of the source material. Okay, so these argon ion physically remove the source material, and the source material travel toward the substrate. Okay, which result into the deposition of the thin film. So dear student, it is very important to understand that this argon ion must have higher energy than the binding energy of the source material. Okay, if let's say if we want, it is very easy for the source material to be get removed from the surface because they have less energy. Okay, at the surface they have 3 degrees of freedom on the surface, and whereas if we want to remove the ions, and if you want to remove the source material from inside, the argon ion must have energy higher than the binding energy of the atom inside the source material. Okay, so these are the key parameters which we need to understand in order to remove the material from the surface or from the inside. Another interesting factor in this apparatus is the applied potential. Okay, so we need a potential which work at a high kilo electron volts. Okay, for the sputtering process we need potential in the range of 3 electron volts to 10 electron volts to 3 kilo electron volts. So now coming toward the key parameter in sputtering. What do you think? What are the key parameters in sputtering? What parameters we need to understand and we need to utilize during the sputtering? Number one key parameter in sputtering deposition is the growth rate and the density of the coating. So it is highly desirable in any kind of thin film deposition devices or apparatuses that the growth rate of the thin film which we want to deposit must be higher, and the density of the coated film should be more. Okay, if we think about in terms of industrial applications, so we need a higher range of the product, too much product in limited time. So in that case we need a higher growth rate. And secondly, the density of material is very important in also in terms of semiconductor applications, because if there is any kind of porosity in the material or is any type of defect in the material, that can really destroy the whole application of that material. So the density and the growth rate are the key parameter in the sputtering deposition. The next key parameter is the uniformity and the smoothness of the deposition. So we need highly uniform film and also very smooth film in order to avoid any type of defect, or in order to avoid any type of deficiency in terms of application of those thin films. Another key parameter which we basically consider in the sputtering deposition is the contamination during the coating. Okay, you know that in sputtering basically highly ionized argon gas or inert gas is to fall or incident on the precursor material or the source material, so that can also damage the electrode on which the source material is placed. So that electrode is basically made up of any kind of metal or some kind of material, so it can also take that material, from the electrode, and it can act as a contaminant and can be transported into the deposited thin film. So, and also there could be any kind of contamination in the environment of the sputtering chamber. So it is highly desirable in terms of getting a better or good quality film that the vacuum chamber or the sputtering chamber is fully evacuated with no contamination, and also the incident inert ions should not interact with the material on which the source material is placed. Okay, and there should be a heat on the surface of the precursor material rather than at the bottom of the precursor material, because that can react the bottom of the material with a material on which this precursor material is placed. Okay, so it can react the electrode with the source material, number one, and number two, it can also cause an evaporation of the electrode material with source material. So that can basically cause a huge kind of contamination. So contamination is a key parameter in the sputtering of the thin films. The next key parameter is the adhesion and coating with the substrate. Dear students, you have to understand that what is basically the importance of the thin film? Basically, if you know that every bulk material has its own properties, okay? So thin film is deposited in order to get different properties from the bulk material. And if the thin film is not connected, is not in better adhesion with the substrate, there will be, we cannot, in the simple word, we cannot achieve what we want to achieve, okay? So adhesion is very important property in order to get a better result. Next key parameter is in the sputtering apparatus is the cathode current density, okay? And so we have to consider the cathode current density in order to ionize our inert gas in the vacuum chamber or in the sputtering chamber. The next key parameter is the discharge voltage, okay? Discharge voltage is very important because with this voltage basically we are getting the number of electron at the cathode, okay? Higher will be the number of electrons in the cathode, there will be a higher rate of the ionization of the inert gas. So if the higher is the range of the ionization of the inert gas, more will be the strike of the inert gas with the source material, and higher will be the rate, or higher will be the sputter yield of the source material. So we will get thin films in higher range and in higher rate, okay? The next thing is the inert gas pressure, and it is also important in the sputtering apparatus. It is very important. It is also an important or key parameter in the sputtering apparatus. So another key parameter is the distance between the target and the substrate, okay? So we have to understand that the distance between the target or the source material and the substrate can affect the rate of the deposition, and this also affect the the rate of deposition, but it is very important in terms of transport of the anion of the ions of inert gas ion toward the substrate, and from the substrate to from inert gas ion to the source material, and then the source material to the substrate. Sputtering yield is basically the outcome of the sputtered deposition, okay? So mean that the thin film which we received after the sputtering deposition, it is defined as the number of the sputtered or dislodged target atoms per projectile ions. So the number of target or dislodged atoms are the atoms from the source materials, okay? They are basically dislodged, they are removed from the source material by highly energetic projectile ions. The sputtering yields depend on the impinging species, okay? The impinging species are basically the inert gas ions. So the sputtering yield will depend on the atomic mass of the inert incident gas ion, and in this case, like usually we use in sputtering apparatus the atomic mass of the argon ions. So the yield is firstly depend on the impinging species, the atomic mass of the impinging species. The target species mean that the source material of the source material or the precursor material and its atomic mass. Binding energy of the target material, it is very important, okay? Because in order to evaporate the source material, the binding energy of the source material must be less than the energy or the energetic energy, like the energy of the incident argon ion or incident inert gas. A relative mass of ions and atoms. Okay, so both of these, the relative mass of the ions and also the atoms of the sputtered species, so both the yield will depend on both. Energy of the impinging species, which is mass and velocity of the argons. Okay, so you know that the energy is very important factor. So in order to remove the source material, we need highly energetic ions, and we have to, in order to get a more yield, the velocity and the mass of the inner ion gas is basically considered, and so the as far as the sputtering device is concerned, the energy of the impinging species depend on the potential difference, which is basically an applied voltage between the cathode and anode, which result in the kinetic energy of the impinging species. Okay, angle of incident of ion is also very important. Okay, so the angle of incidence we will discuss in the later slide, that how the angle of incident basically result into increase in the sputter yield. But dear students, you have to understand that with the different angle of incidence of the ion have a different impact on the evaporation of the source material, so it is also key parameter in sputter yield. Dear students, now coming toward the growth rate of the sputtered deposited thin film, what do you think? What are the key parameters on which the growth rate of the deposited film depends? Okay, so the growth rate in the sputtering depend on the ion current density. Okay, basically the ion, what is the current density, how much are the number of the ions which are basically impinging on the source material. So this means that higher will be the density of the ion, higher will be the growth rate. Number of atoms dislodged per ions. Okay, another key parameter on which growth rate depend. So number one is the number of ions or the ion current density. Number two is the number of atoms which will be removed by the incident ions from the source material. So higher will be the number of atoms removed per ion, higher will be the growth rate. Atomic mass of the target material is also another factor. And this factor basically is key in the sense, in order to remove the source material. So the higher, like if we say that the mass of the inert ion is greater, it will easily remove or dislodge the target or the source material. Density of the source material and also the density of the impinging ion is also a key factor in order to have a higher growth rate. So the growth rate basically is demonstrated by an equation, JSM divided by rho. Okay, so J and S are basically the current density, and M is the mass of the target or the source material, and rho is the density of both the ion and the source materials. Okay, now there are some issues, in terms of depositing the alloys during the sputter deposition. You have to, dear student, you have to understand that the sputtering deposition, in sputtering deposition we can deposit wide range of source materials, and which include alloys, compounds, metals, etc. So there are some issues during the deposition of the alloys, because alloys are complex kind of materials. So we use different types of elements in the alloys, and they have different vapor pressure. So the evaporation of the different element inside the sputtering chamber will be different, which will cause different types of issues during the sputter deposition. If a target material is made up of several atoms with different sputtering yield, initial film composition can be off. So it will be very difficult, because we are using several atoms, we are using different types of atoms in alloys. So the sputtering yield, when these types of when different types of atoms are get evaporated, they have different vapor pressure. So as a result, this actual composition which we want to get will be very difficult, and initially we will get a non-uniform or different type of composition of thin film to which we required. So we will get different film than required film. The sputtering yield variation are smaller compared to the vapor pressure variation. So dear students, you have to understand the vapor pressure of the element is different. So the variation in the alloys will depend more on the vapor pressure as compared to the sputtering yield. The yield variation will be smaller, but the vapor pressure inside the chamber will be variation will be higher, because we are using different kind of atoms, because we are using alloys. So the vapor pressure variation will be more. Therefore, the initial layer of the film will be more closely related to the target composition. So it will be more about the target composition of the target rather than our desired result. So our initial film layer will be a replica of the target rather than the result which we want to achieve. Initial disparities will eventually correct themselves as the amount of the faster sputtering component at the target reduces. Okay. As with the given time, the faster sputtering component of the target will reduce, and this will turn our film into a uniform film, but after some time. So dear students, what do you think, what will be a problem, what will be the issues with the deposition of the compounds during the sputtering process? You know that compound is basically a complex structure with different kind of elements. So every element have different vapor pressure, and the impingement, the removal of those elements will be different for the different impingement of the incident ions. Okay, so the temperature is more concerned for the source material, and in order to get it easily evaporated, we need a limited range of temperature, which is basically we need to heat a source material in a limited range in order to get easily evaporated due to incident ions. So if the target temperature is too low, okay, if the source material temperature is too low, the ion bombardment can result into amorphization of the crystal target. Okay, so the temperature range is highly concerned in compounds during the sputtering process, because we want to evaporate a compound and an element of the compound have a different vapor pressure, so it is good to heat the source material in certain range and then evaporate it. If the source material have a less heat, okay, it has a low temperature, so it will be difficult to get evaporate the source material, and they basically cause amorphization, okay. They form a crystal structure on the cathode rather than they get evaporated, okay. So we need a certain limitation of the temperature. In case if we are increasing the target temperature, the annealed surface, the surface will get annealed, okay. So you know that in order to get a better film, we have to set a temperature range, and annealing is basically a process in which the structure is heated and it's turned into a certain type of crystal structure. So we have to limit the temperature of the sputtering source in a certain range, that it don't get amorphized, it don't turn into an amorphous, and it also don't annealed and turn into a real crystal structure. So in compounds we have to set a temperature range for the source material. It should be between the amorphization and crystallization, so the material will not it should be not low, and it should not be too much higher to turn a structure either into amorphous or into a crystal. So now, what are the requirement of getting a uniform sputter deposition? There are some physical parameters which we need to adjust during the sputtering in order to get a uniform sputter deposition. Number one is the pressure. Pressure inside the sputtering chamber is very important. If the pressure inside the sputtering chamber is low, it will cause direct flow, which will result in less uniformity of the sputtered thin film. In case if we have a higher vapor pressure, this will result into isotropic and flow, and it will cause a better coverage or better density with full cover of the substrate. So we will get better deposited thin film at higher pressures. Uniform film also required larger target. Okay, so uniform deposition need the target or source material which is placed on the larger areas. Okay, so the area will be more, then it will be easy for the impinging species, it will be easy for the ion to strike with the more source material, and more source material will be evaporated, and it will basically get better uniformity. Surface morphology of the substrate. So uniformity also depend on the surface morphology of the substrate. Okay, we need a substrate with high uniformity. Okay, so it will be very easy for the source material to deposit on the substrate. So surface morphology is also concerned in order to get uniform deposition. Temperature of the ionized plasma, source material and substrate is also key factor. Okay, as I discussed previously that the temperature of the source material should be in certain range. Okay, it should not be lower and it should not be higher, because they can cause the crystallization and amorphization if they are low or high. So the uniformity of the deposited film is basically concerned about the temperature of the source material and also the temperature of the ionized plasma. Ionized plasma is basically the ionized argon gas inside the sputtering chamber with electrons. Okay, so there should be a certain range of the temperature of the ionized plasma and source material in order and the target material in order to get a uniform deposition. And also the uniformity of the deposition depend on the rotation of the substrate. Dear student, as I initially explained the simple image of the simple schematic of the sputtering device, and I have not explained that the importance of rotation in that image. You can check that slide. But the rotation of the substrate is very important, okay, because we want to get a uniform deposition. If we rotate the substrate with a certain speed, the film which we get, the material which get evaporated, the source material which get evaporated, will basically easily deposit it on the different area of the substrate, and at the end, due to rotation, we will get highly uniform film. So the rotation is very important in terms of uniform deposition. It is not only important in the high vacuum based techniques, but the rotation is also important in solution based deposition techniques of the thin films, and that is the reason due to which many of the solution based techniques is using the rotation devices or in order to deposit or in order to get a uniform coating over the substrate. So the rotation of the rate of the substrate is also important in order to get uniform sputtered thin film. Now coming toward the angle of incident of the projectile. As I previously discussed in sputtering yield slide, that the angle of incidence of projectile is very important. Dear student, you have to understand, number one, that what is the angle of incident of the projectile ions, okay? Number two, what is the morphology of the substrate on which we will deposit the source material, and what is the surface morphology of the source material. So we have to consider all these three: angle of incident or angle of strike of projectile ions, number one. Number two, the morphology of the source material, okay? Morphology is mean that what is the appearance of the source material. And number three, the morphology or the surface of the substrate on which we will deposit the source material. So I will explain all of these one by one. The sputtering yield depend on the roughness of the target surface, okay? It's depend on the surface of the target or precursor material, okay? So such as with unevenness or non-uniformity of the surface will result in change in the angle of incident and result in yield variation, okay? So you can easily understand that if the source material has a different morphology at different points. So first, the angle of incident of ion initially when it is coming toward the source material is different, okay? And when it strike with the source material, you know that if the source material at a different point have a variable angle, so the incident ion will strike in different angle with the source material. So the initial angle of the source material is of the incident ion is basically changing on the surface of the source material, okay, or precursor material. When it changes, the yield will change, because the angle of incident of ion is not the same when it gets taught, it's just changed at the surface. So the surface uniformity of the source material is also important in order to get higher yield, okay? And when the source material get evaporated at certain angle of incident of ion, then they travel toward the substrate. Now here also is concern about the surface of the substrate on which they will deposit it. So it should the surface of substrate. But interesting fact here to note is that if the surface of the substrate is of different shape, the deposition rate will be same, but the adhesion with the surface will be different, okay? So if the surface is more roughly shaped, or it has a higher, like at atomic scale, then it will have a higher surface energy and will get a better adhesion. But you have to understand, students, that the angle of incident of projectile is firstly very important, and it's depend on the angle with which the projectile ions are traveling and the angle with which the source material are placed on the electrode, okay? So both the angle of both will result into net sputtering yield. The angle of incident is explained on the basis of the growth, on the basis of the sputtering yield, okay? So like this, initially at smaller angle of incident of the projectile ions, the yield is less. However, with the increase in the angle, like here, with the increase in the angle, the yield basically increasing, and there is a certain range of the incident angle at which the yield become maximum, okay? So in this slide we are very clear that the yield, the resultant thin film, is depend on the angle of incident of the projectile ions, number one, and also the angle with which the source material is placed on the electrode. So dear students, sputtering is basically a momentum exchange mechanism. As you know that in sputtering process, the highly energetic ions, they have a certain amount of momentum and energy fall or incident on the source or the target material. So the certain amount of the momentum which is associated with the incident ion is basically transferred into the source material, and with the transformation of the momentum from the incident ion will cause the evaporation of the source material from the surface, from the surface of the surface. So there are two different types of mechanism take place during the momentum exchange of the ion with the source material. Number one is the primary knock-on, okay? In this process, the incident ion basically strike with the atom which is placed on the surface of the source material. So the atom of the surface with the incident ion will travel inside the source material and will deflect it by the atom inside the source material, will result into travel toward the surface of the source material, and due to higher energy of this the traveled atom will result into removal of the atom which is present at the surface of the source material as a sputtered material. So this is a primary knock-on mechanism. There is also another type of mechanism which is low energy knock-on mechanism, and in this low energy knock-on mechanism the incident ion basically strike with the atom which is placed at the surface, okay, here. So the atom at the surface will move inward, however transferred certain type of energy with the atom which is closer to the to this target atom, and the atom which is closer will get evaporated as a sputtered material. So the total energy is represented by the equation, which is basically the energy which is of the transmission of the sputtered material is basically given by the equation. It's depend on the mass of the target or material, mass of the ions, and the input energy which is basically given via applied potential and via incident ions. The energy of reflection will basically depend on the mass of the target ions and mass of the target material and mass of the incident ions and the input energy. So now coming toward the breakdown voltage during the sputtering. What will be the voltage required to ionize inert gas? The breakdown voltage is defined as the voltage required to ionize the inert gas. So we have cathode and anode in the sputtering apparatus, and we have an inert gas which is basically an argon gas. Upon the application of high electric potential, there is a threshold point, okay, and where inert gas start to ionize is a breakdown voltage. So what this term mean? Breakdown voltage is a voltage which we require to ionize the inert gas inside the sputtering chamber. In order to ionize the gas inside the sputtering chamber, there are in the sputtering device there are cathodes and anode. They are connected with high potential, and this high potential basically draw or move the electrons with higher energy toward the inert gas ions, and they get ionized, those inert gas ions. So they get ionized the inert gas and result into ions. So the breakdown voltage is the minimum voltage required to ionize the inert gas inside the sputtering chamber. Breakdown voltage depend on electrodes, the nature of the electrode, okay, the pressure inside the chamber, and the applied potential across the electrodes. So dear student, now coming toward what will be the current and the voltage behavior inside the sputtering apparatus. As you know that with the application of external potential, with the application of voltage, the current is generated or the electrons draw to travel from the cathode toward the anode. So these electrons basically generate a current. It is from the cathode, but it has also an impact of the ionization of the argon or the inert gas, which is basically present inside the sputter apparatus. So the current behavior with the applied potential is basically divided into different regions, which basically are dependent on the ionization of the inert gas which is present inside the chamber. The first region is the background ionization. So when the ions are basically, when the electrons traveling from the cathodes, if they have lesser energy or they are in lesser amount, there will be a kind of background ionization with the inert gases. So with the time, these incident electrons basically will cause a saturation and will impinge or will strike more with the ions which are with the inert gas atoms which are present inside the chamber, and this behavior, this region is basically known as the ohmic region. So now when the number of electrons are basically striking with the ions get more, and they have more energy, and they will cause a certain type of a start up of ionization in a certain region, which is basically known as the Townsend region. Okay, so the incident ion are basically electrons are basically ionizing trying to ionize the argon or inert gas ion, and this is the point where the ions basically get ionized, and this point and this region is basically known as the breakdown of voltage region at which the ions get ionized. Okay, and as a whole, from where the electrons are trying to get ionized argon to the region where the argon ion or where the inert ion get ionized to the normal region is known as the Townsend region, or the region where the ionization started. So after that, after the Townsend region, at the certain voltage, at the specific voltage, the current will remain and will increase. And however, when the current reach to a certain limit, there is a start of the abnormal region where there will be an increase in the current and voltage, and this will be the region from where the discharge or from where the sputtering of the source material will start. So sputtering phenomenon or the evaporation of the source material will start in the abnormal region, and the current and voltage at this region will be at its maximum. So now coming toward the variation in the sputtering device. Dear students, till now we have discussed about the simple sputtering apparatus, but sputtering apparatus can be used in order to deposit a very complex materials. Okay, but how we can utilize the sputtering apparatus in a complex material to deposit a complex thin film on the substrate? So for this, as far as we discussed previously about the deposition of alloys and compounds, But if we have different alloys or different types of alloys and different types of compound, and we want to deposit all those different types of alloys and compound, what we need to at the same time what we need to modify in the sputtering device. You know that the sputtering device is basically one cathode on which the source material is placed. So they can at the same time, the sputtering device basically can deposit one type of element or compound as a thin film on the substrate. But this can be modified, and there are a lot of sputtering devices available which can deposit different types of materials on the substrate material. So for this, basically source material is placed on the different or source material is placed on the different, it could be cathode or different cathodes are on different places inside the chamber, like this and this. These are the two different source material, okay, and they are basically covered with a shutter or a splitter. So these source materials are placed in complex system. There are a lot of like source material like this placed inside the chamber. So we can at the same time these material can get evaporated by the argon ion or by the inert gas ion, and they get deposited on the substrate. But we can also control the deposition of each of the source material, okay, by shutter. Let's say if you want to deposit this material, and then we will in the complex system the other material is covered with the shutter, and this material get evaporated, and if you want to get evaporate this material, okay, in the complex sputtering device, and then we will cover the other sputtering materials with a shutter, and this material source material is get evaporated by the argon ions and deposited onto a substrate. Now at the same time, if you want to deposit complex source materials as a one thin film, we basically the shutter is removed from both of or many of the source materials, and they are targeted by the inert gases like here this and also these, and they get evaporated and deposited onto a substrate. So we can play with the sputtering device. It's not necessary that the sputtering can only deposit require one source material. In one sputtering apparatus we can have a lot of source material, and we can get a lot of complex thin films from these apparatuses. Okay, so there is basically in a summary, there could be a single target source material in the sputtering devices, but there could be a multi-target sources inside these sputtering apparatuses. Now another important thing is that the sputtering device can be vary with the substrate biasing, okay, so that can basically control the deposition of the different types of source material having different types of ionizations or plasmas. So that can also mean, what this means, that we can basically in multiple sputtering apparatuses we can also bias the substrate material, and with this bias we can control the deposition of the different materials or different complex materials. So another thing is that the variation can be done by the admittance of the reactive gases apart from the inert gas, okay. So like, you know, in order to get more complex films, as per requirement, like what if we need, we can incorporate the different types of reaction gases inside the chamber, so they can get ionized, they can get evaporated, and they can get react with the argon or inorganic ions, and they can get deposited onto substrate. So with this, all this variation, we can get highly complex thin films. So now coming toward the conclusion, sputtering is the process of ejection of the source or the target material upon the impingement of highly energetic projectile ions. The inert ion, the inert argon ion, strike the source or the target material present at the cathode in the sputtering chamber, which result into evaporation and deposition. The flux of the sputtering material is intercepted by the surface of the substrate. So both the flux of the sputtered material and the surface of the substrate on which the sputtered material will be deposited, both depend on each other, both are interdependent in order to get thin film. Cathode current, discharge voltage, which is the voltage between the electrode and anode inside the sputtering device, pressure, and stand on distance are the key physical processing variable. Okay, so for deposition, cathode current, discharge voltage between the cathode and anode, pressure inside the chamber, and the distance between the cathode and anode, all of these are the key parameters. Mono and multi-phase deposition can be done with sputtering apparatuses. Substrate bias and temperature influence the quality of the deposited thin films. So dear students, for today it's the end of the lecture, and I hope all of you have understand the sputtering phenomena, and in next lecture we will discuss other physical vapor deposition techniques. For today, thank you.